Hey everyone, and welcome to my first video, an overview of the solid principles, with me, James, here on JC#. Following this video, I'll be deep diving into each principle individually with code-along guides. But first, I wanted to make sure that whether you're new to Solid or a returning veteran, we know where this all started and why. So, what are the solid principles, and where did they come from? Well, the solid principles, some of which were around for some time prior, were really pushed to the forefront of engineering standards by Uncle Bob in the early 2000s, as part of his paper Design Principles and Design Patterns. Interestingly, Uncle Bob's paper makes no mention of the mnemonic acronym SOLID, instead referring to them as the first 5 principles of class design. There are in fact a further 6, which are targeted at packages or libraries and their cohesion and coupling between one another. The 11 principles combined make up the principles of object-oriented design. To our focus, as we know them today, the solid principles are intended to help make software more understandable, more flexible, and more maintainable. So, let's take a look at the single responsibility principle, or SRP first. Made popular in 2003 by Uncle Bob, this principle states that every class in a computer program should have a responsibility over a single part of that program's functionality, and all of that class's services should be narrowly aligned with that responsibility and not overlapping with other classes. Uncle Bob defined it as a class should have one and only one reason to change. If this isn't the case, it's considered as breaking SRP. Next, we have the open-close principle, or OCP. Bertrand Meyer is generally credited as the origin for the term open-closed principle, which he first wrote about in 1988 in a book called Object-Oriented Software Construction. Originally, this was designed to be implemented through inheritance using parent and subclasses. However, over the years, other developers discovered that this form of inheritance introduced tight coupling, where the subclasses depended on the implementation of their parent classes. That's why it was later redefined as the polymorphic open-close principle. Today, we use interfaces instead of parent classes, allowing us different implementations that can easily be substituted. Thus, the interface is closed to the modification, but you can extend the functionality by providing a new implementation. We'll talk more about polymorphism in a later video, but it's really important to understand that the approach that we use today gives us an additional layer of abstraction, enabling loose coupling, as the implementations of the interface are completely independent and don't share any code. Next up, LISKOV substitution principle. Barbara LISKOV introduces us to this principle during a conference keynote speech in 1988. And I'll be honest, I find this principle the most complex to understand, but to explain it easily, let's look at ducks, because ducks are awesome. Let's say you have a real duck and a toy duck, and you need to make them swim. LSP says that you should be able to use the base class or interface instead of the actual implementation and get the same result. If it's not the same result, then it breaks LSP. And what breaks LSP here is that the toy duck must be turned on first. I know what you're thinking. In the call, just check if it's a toy duck or a real duck and then turn it on if needed. But that breaks open-close principle because you'd need to do that everywhere that you ask a duck to swim, real or not, and that doesn't make for a stable program. In fact, the solution is to have the toy duck automatically turn itself on when you ask it to swim, so that it behaves just like the real duck. This could cause problems itself, but it's more likely you'll have issues not turning the duck on. And we can solve those issues easily by using explicit interface implementations. Remember polymorphism from the OCP we just covered? So, let's look at interface segregation principle, or ISP, next. ISP was first created and used by Uncle Bob, and it's really easy to get to grips with. So let's rattle through. Consider 2 types of developers, governed by a generic interface containing details such as an email or a name, etc. Some of the properties in here, such as monthly salary perhaps, would only be applicable to a full-time employee, whereas hourly rate might only be needed for a contractor. ISP tells us that each object should only ever implement what it needs, and in this example, the full-time employee doesn't need the hourly rate, and the contractor doesn't need the monthly salary. We can split all of this out and have a generic interface that defines the basics of what each employee should have as a standard. And then we can have individual interfaces for full-time employees and contractors that are totally different. So neither of them needs to implement anything it doesn't need. Finally, we've got dependency inversion principle, or DIP. Again, we can thank Uncle Bob for postulating this back in 1996. DIP is concerned with reducing dependencies on low-level objects in high-level objects. Both should depend on abstractions, and those abstractions should not depend on details. But details should depend on abstractions. It sounds terribly confusing, so let's break it down with a really straightforward example. Let's say you've enjoyed this video so much you want to go ahead and get a notification when my next video is released. If you do, great, hit the like, subscribe and ring the notification bell. Now, for argument's sake, those notifications come in two forms, an email and a text message. When we come to sending a notification from the notification class, we're dependent on both the email and text message classes. We'd have to call both directly, and that goes against DIP. If we think back to single responsibility as well, we don't want such tightly coupled code where it can be avoided, right? So, let's put in some abstraction. Something that the notification class can rely on, and remove the dependency to the email and text message classes. Now, the email and text message classes can implement the contract from the interface, and the notification class can simply look to the contract without really caring what's beneath it. So, in summary then, we've looked at the single responsibility principle. Classes should have one reason only to change. The open-close principle. Open to extension, but closed to modification. The LISKOV substitution principle. Objects and sub-objects must be interchangeable without breaking the program. Interface segregation principle. No code should be forced to depend on methods it does not use. And finally, dependency inversion principle. You should depend upon abstractions, not concretions. All of these together make up the solid principles of object-oriented design. And what you'll find as you code with these principles more is that they start to interlace with each other, which is fine. That's what they're there for. I hope you've enjoyed this really brief summary. As mentioned at the start, I'll be doing individual deep dives on all of these principles in an upcoming series of videos, so please keep an eye out for those if you're interested. Until next time, thank you for watching.